रिकॉर्ड भी ऑन रिकॉर्डिंग ऑन कर दी है।
हाँ ठीक है।
भावना यू कैन स्टार्ट। सॉरी
मेरे
मानस।
को हाँ ठीक है। So a very warm welcome. So we are a team that is currently working on materials and devices for biosensor, which is including both the chemical and the biochemical device. And the target that we are having with this particular device is the glucose testing. So in our team, we have Pranav Manyar, I Manas, and along with me is Bhavna. Moving to the next slide, we will be discussing that what exactly is glucose testing. So there are two type of diabetes that we know. First is the type 1 diabetes and type 2 diabetes. And in diabetes, the actual target hormone is the insulin. So due to the insulin imbalance in the body and the glucose level imbalance in the body, the uh, case of glucose sugar or the blood sugar comes into action. So why glucose monitoring is essential is the diabetic patients need a time to time check of their glucose level so that they can maintain their medicines as well as they can have a good schedule with respect to the diabetes. Moving on to what exactly biosensors are. So when we talk about the biosensors, so they are the analytical devices that will convert a biological response into an electrical signal. In if we talk about our particular own structure, so we will be having a receptant molecule that will be interacting with the target molecule that will be an antigen or a particular molecule in the blood. And these particular biological responses will be ultimately converted to the electrical signals that we will actually decode in order to get the value of the blood sugar. The applications area are in the field of medical diagnostic, environmental monitoring and creating sensors. And the major components of this particular biosensor is the bioreceptor, which is taking the signals from the receptors, and the transducers. Now, talking about why exactly we need the biosensors. So, first of all, it saves the times and the labor. If we specifically talk about the glucose testing, the person needs to every time prick the needle in order to check the blood sugar. But if we have an inbuilt in vivo biosensor, then it will be a very smooth process. Second is it will give the real time data along with high precision because it is directly in contact with the blood. Along with that, it will be cost effective because the polymers that we are going to discuss with respect to adhesive and the bioreceptors will be cost effective, and it will enhance the selectivity of the particular bioreceptor with respect to the target molecule, that is insulin in our case.
So the proposed design of the biosensor is that there will be three layers. The first layer is adhesive layer, which will be attached to the blood vessel, and the next layer will be a transducing biopolymer, and the next layer will be a receptor biomolecule. So the adhesive layer is a substrate that gives the primary mechanical support for the entire system, and bioreceptor is specific to the analyte of interest. In our case, it is glucose, and the transducing biopolymer helps in converting the required signals into the results we want to look into. That is the level of glucose. Next slide. So the choice of adhesive in our biosensor is a hydrogel of catechol alginate, which can be used as an adhesive. Alginate is a natural mucoadhesive which can be uh, attached to any muco substances like our blood cells or any uh, biosubstances. And uh, catechol is found to enhance the mucoadhesive characteristics of alginate by forming strong irreversible covalent bonds with amine. Next slide. For the enzyme-based receptors for getting the sense for sensing glucose levels in blood, there are three methods. One is glucose oxidase method, which is an electrochemical method. Another is phenyl boronic acid based receptors, which are uh, um, bio-based, which is a bio-based method, and the other one is non-enzymatic metal-based catalyst, which again is a electrochemical method. So in our case, we'll discuss about phenyl boronic acid based receptors. Yeah, next slide. So for glucose responsive polymer, we have selected a phenyl boronic acid based receptor as phenyl boronic acid can react with glucose to form cyclic boronate ester. So the phenyl boronic acid is uh, conjugated with a polymer, and it forms a copolymer, which is given here, which can be used as a glucose responsive polymer. This polymer will swell and deswell based on the degree of water absorption, which depends on the glucose concentration in the blood upon contact due to the presence of PBA moieties. Yeah. Next. So to synthesize the particular glucose responsive biopolymer which we discussed in the previous slide, we need a polystyrene B polyacrylic acid polymer, which is a block polymer. Uh, so this can be coupled with a 3-amino phenylboronic acid at the portion of polyacrylic acid blocks to form the responsive biopolymer. So these are the structures of polystyrene B polyacrylic acid block polymer and 3-amino phenylboronic acid. Next. For glucose sensing biopolymer, that is to transduce the signals, we combine or make a composite of glucose responsive polymer, which was discussed earlier, with carbon nanotubes. So as the polymer swells or deswells in the presence of glucose, it affects the distribution profile of conductive carbon nanotubes, resulting in a more pronounced sensitivity to electrical percolation. So this can be used with adhesive layer because catechol is commercially available due to its ability to form bioconjunction with carboxylic acid and amines, and the polymer which we discussed has an carboxylic acid group, so it can be conjugated with catechol alginate to form the biosensor which we are discussing about.
Yeah, so now talking about the cost analysis of the biosensor that we made. After this, we'll look at the market analysis as well, in which we'll compare the general glucose measurement tests that are available. So in our test, we are using hydrogel adhesive layer, in which the catechol chitosan hydrogel is used, and its cost is around 100 to 300 per unit. Apart from that, phenyl boronic acid polymer is used, which in combination with carbon nanotubes helps in the biosensor part, transferring the biochemical sensor to electrical signal. And apart from that, so these are the corresponding costs, estimated costs that they have. Apart from that, electronics, like general devices, which cost around 2 to 4K per device. So this is, we are measuring for continuous monitoring, and because of that, this cost might be a bit high. And yeah, so for continuous glucose monitoring, the overall cost approximately comes out to be in range of 5,000 to 8,000. Given that the cost of the biosensor itself is 800 to 1,500, and it should be replaced like every week or two. So this is, when mass produced, this can be further optimized, and cost can be made to come in affordable range. So yeah, this is a very good choice. Coming to market analysis, the general tests that are available over are the oral glucose tolerance test, which you have to be on fasting, and after and continuous testing every hour for the next 2 3 hours. So you have to do 3 4 tests, and the cost comes around 400 rupees for the entire set. And this is fasting blood sugar level test. This is a regular medical examination, and it measures the amount of glucose present in bloodstream, and cost per test is around 80 rupees. So considering 6 tests per day, it would cost around 500. After that, HbA1c test, which is hemoglobin test, and this measures the average blood glucose level, which has been there for past 2 3 months, and its cost is around 400 to 1000. Apart from that, the general uh, continuous glucose monitoring devices that are available in the market, their cost is around 25,000 to 50,000, and the sensor cost, which has to be replaced every uh, now and then, every week, let's say, so its cost is around 3,000 to 6,000. So yeah, this is a expensive method, and our method that we are producing, that we are giving, is a cost effective method and can be used. Yeah, so concluding the uh, entire discussion, so yeah, glucose biosensor design proposes an adhesive hydrogel layer combined with phenyl boronic acid and carbon nanotubules for continuous glucose measurement. And yeah, this device focuses on real-time, non-invasive glucose monitoring, improving the diabetes management through convenient long-term use. These were the materials that were used in our proposed solution, the polymers used, and the estimated cost, as we can see, is quite low as compared to the market analysis that we've done. And by reducing the frequency of sensor replacement and lowering the cost, this biosensor offers a sustainable, affordable, and efficient option for continuous glucose monitoring, and significantly improving the quality of life for diabetic patients. And that's it. Thank you. Oh, yeah, recording.